Hey everybody, this is Larry. This is day 17 of the August Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Very late day. I am a sicko, you know. I just came back from my run, took a little bit of shower, of course, because it's hot. But I did a 6-mile run, 10K, nothing too much, at midnight because that's the only time I could get it in. I hope to. I want to say I would pass out after this, but I still have to do the daily contest or the weekly contest. So it's gonna be a late night. It's already 2 a.m. in case you're wondering. I did eat before I did this video, so that I'm not like starving. So that part is good. But I am still an idiot, or maybe a psycho, or maybe both. In any case, I hope everyone's having a great weekend. Without further ado, let's take a look at without further ado, let's take a look at well, today's poem and go. Sorry, it is 2 and who is messaging me at 2 a.m.? Let me know in the comments. Do people message you at 2 a.m.? Like, I guess okay. I mean, I guess I'm degenerate, but I just thought other people would not be as degenerate. I don't know. Yeah, what else was I gonna say? Yeah, let's go. Sorry, friends, I'm just a little bit. My head. Okay. There's a thing in my apartment. I'm not gonna talk about it. Sorry, friend, I'm just a little distracted. But let's go. You know, we can do this one without focused, right? But I'm wasting your time a little bit. My apologies. It's just very late night, and I still got. Do the contest. What am I doing with my life? I don't know. All right, let's go. Alice plays the game. Card game 21 starts with 0 points, or 21 like blackjack. Okay, I was thinking 24 for some reason. 24 is that game. What is 24? 24 is that game where you're given 4 numbers and you try to figure out ways to get 24. Honestly, that's what I thought I was gonna. I mean, I don't know. I mean, I for some reason I mean, clearly they're 2 different games, but yeah, that's basically what I was confused about. All right, 0 points. Draw cards while she has less than K points. During each draw, she gains an integer number of points randomly from 1 to max points, where max points is an integer. I assume it is uniformly distributed, and if I had read to the next part, they would tell me that. In any case, stops drawing number when she gets K or more points. Return the probability that Alice has N or fewer points. Okay. It's a little bit awkward to say, and when that happens, I look at the examples and just say it out loud, right? So you want to return the probability that I mean, you have 1 and you're trying to draw from 1 to 10. You want to get the probability that she has less than 10 points. If she gets more than 1 point, she stops. Okay. It's a little bit awkward for sure. But yeah, so I mean, I think there are a couple ways you could do it. You could do it tops down. You could do it bottoms up. I mean, this is clearly dynamic programming. Is it that clearly? I don't know. But in any case, you can just think of it recursively in either case, which is that maybe you have a function. I'm going to call it go because it's late. I cannot name things, and it's going to be variation anyway. It's just, if I don't have anything to name, I just call it go, which is not a good interview advice, by the way. But also, please don't do your interviews at 2 a.m. So that's my excuse. In any case, yeah, so maybe you have like current points, and that's it, right? Like none of these things matter with respect to the current score. So then now, and of course, I'm just going to put in memorization. I'm going to say that this is not a dynamic programming or memorization video. Sometimes I do go into it a bit and try to explain dynamic program memorization, but honestly, I've solved this one before, and I probably went into it more detail because 2 years ago I probably went in more details in dynamic programming or memorization. So definitely check that out. I don't know what I did that time. I mean, I just see the self icon or whatever. But yeah, so maybe I do it really funky, and maybe I do wrong answers. But in any case, here we just every time the key part about memorization and dynamic programming, right? I mean, it's not quite one-to-one per se, but the key thing is that whenever you get an input, the same thing happens every time to that input, or the same output happens every time, right? Because then now, in a way, you're memorizing it, because every time you get it, you put it back out. It's the same thing. You don't have to do it again. That's the key point about memorization. There's no states or no hidden states or what's it called? Side effects is what I want to say, right? So anyway, so if current is greater than or equal to k, then we have to stop. And if we stop, then if current is less than or equal to n, then this is 100% or 1.0, right? Else returns 0.0, because then it's 0%. That's basically your base case. And then now we just actually I should have looked at the constraints. Maybe I lied. Maybe I did lie, huh? No. Maybe I did lie. Maybe this is wrong. This is gonna be too slow. I didn't think through it. This is embarrassing. Yeah, the way that I write it is no other way. This is embarrassing. I didn't look at the constraint. That's the truth of the matter. I did not look at the constraint, and it is embarrassing because the way that I do it, right? Maybe I was going to already write a for loop, right, for I in range. I just finished writing it. I mean, because we're already here, but this is not going to work. And I recognize this now. But basically, you have p is equal to 0, where p is the probability, whatever this is, when you return, right? Alice n or fewer points, right? Ends with n or fewer points. And then the idea here is that, well, we just sum up all the current plus I divided by max points, because those are equal probability, 1 over p or something like that. You can also take this out, right? So then you could do instead. But, and this will be right, right? Pretty straightforward. Yeah, this will be right. The problem is that it is going to be too slow, right? And I really should have recognized this. I actually really do this, but maybe today I'm just really off, because if you try like 10 to the 4th and 10 to the 4th, this will probably time out. Did I mess up? Oh, K. What is K again? Yeah, okay, whatever. I think K, that is a good enough K, right? And this will time out even with memorization, right? See, there you go. And like I said, I usually do, even if I don't say it on stream. And today, I mean, it is what it is. Hey, listen, even I will make mistakes. But in any case, yeah. And the reason is because, well, how many states are there, right? Current can go from 0 to n, or yeah, is it n? I forget what variable, right? It goes up to k, sorry. Because once it gets to k, it stops. Well, it's going to be up to k plus max points, right? Because you could, technically, if you want to say it's k minus 1, then you plus max points. So this is the number, right? Which is, let's just say, max point is 10 to the 4th, k is 10 to the 4th, so this is, well, 2 times 10 to the 4th, right? But then here, each input does O of max points time, right? Mad points? Maybe it is mad points. Max points time, which is also another 10 to the 4th. And then because there are this many inputs, each input does this, it is symbol 2 times 10 to the 8, right? Oh, sorry. Yeah. More or less. I mean, it's a big O, whatever, you could do math, which is anyway too slow, is my point. And of course, I recognize this because I just didn't look at constraints, really, to be honest. A little bit sloppy on my part, my apologies, but it gives me a chance to explain dynamic programming anyway, apparently. So, okay. And of course, if this is 10 to the 3rd, then there'll be 1,000 square, which would be 1,000,000, and that would be, yeah, and that would be fast enough, right? but unfortunately, that is not the case. We have 10 to the fourth, and therefore we have to figure out a better way. Huh. Well, okay. I mean, I'm just unhappy about what I did. I mean, but actually, honestly, I thought I would be more unhappy, but I think I had to do it this way anyway. But I would also say this is not a easy idea, and it is not a easy technique, which is crazy, right? But it's fine actually, because I think this is how I would want to explain it anyway. So you do this and it's too slow, right? And you figure out, well, I mean, there's really not much to say, right? In that, well, now you need an optimization, right? How do I come up with an optimization? And the way to come up with an optimization is, for me, and you know, there are many ways to do this, right? Or probably, I don't know. I don't know how many ways there are, but I know of one of the ways. And I'm a little bit stalling a little bit because I'm trying to bring up the drawing board, right? Okay, so I want to, I don't know how to get the code and still kind of show this at the same time. Like I mean, I could figure it out. It's just that it takes a while. I haven't updated how to set this up in a while. I'm writing my pen, but okay. Let me actually put this off for a second, and I want you to focus. And again, this is actually I consider this an advanced technique, honestly, especially if you're more of a beginner. Nowadays, Leetcode has been exploiting this idea more, but I think it's still a tricky idea. So definitely don't feel bad if you are not able to get it. It is marked as a medium, but it's a very tough medium that you have to figure out. And it comes with a visualization. And the reason why I come back to the code is that I want you to remember this, right? Basically, you could say, I mean, you could write this in a number of ways because it's just a formula. But if you look at this, then now you can say that maybe f of 0 is equal to f of 1 plus, you know, you just want to write it out. And let's just say max points is 10. This is the 1, right? 2, and maybe you could have written this backwards, but you know, dot, right? Okay. Remember this, right? And this is as a result of this for loop. Hopefully that makes sense because I'm going to bring up the drawing board. Okay, so now, I mean, I'm going to write the same thing, right? I'm going to write the same thing, which is that, yeah, f of 0 is equal to, say, f of 1. I'm not going to write all f of 10, but f of 10 maybe in this case, right? Right? Yeah, right? Okay, so that's fine, right? And if you want to write it out, we can also write f of 1 is equal to f of 2 plus f of 3 plus plus f of 11. And honestly, maybe you could recognize this as a, maybe as a sort of, you know, how do I write it? How do I say this? I mean, well, one thing that I would say is that maybe you could recognize that this is similar, not quite as, say, the Fibonacci sequence, right? If for Fibonacci, at least the idea of the recursion is that you only take, you know, these two, for example. But that's not super important because it still doesn't help you when you have max points that are really big, right? Because even if you do Fibonacci in a way such that it's very big, that part isn't interesting because there is actually an other solution as a result of the Fibonacci idea, which is the Q matrix, which you can Google. It's just called Q matrix and matrix exponentiation, fast matrix exponentiation. I'm saying that wrong. You get the idea, but we are not going to do it, right? I don't think that's necessary, though you can do it for sure. So I don't know. And honestly, I'm trying to think whether that is an easy idea. That is an easier idea than what I'm going to explain. But in any case, the idea that I want to exploit or play around with this problem, right, now is this idea of sliding window, right? What do I mean? Well, if we do these things in the right order, right, then what happens? Well, let's just say you have an array. Your array looks like that apparently, right? Then now, and maybe I won't go up to 10, but you get the idea. I'm just going to draw some stuff. Well, what do I mean, right? That means that, let's start in the middle. Oops. Let's start in the middle. You have this cell. What is this cell? Well, this cell is just the sum of these numbers, right? And then what's the sum of this cell? Or so you sorry, let me go back a second. So this is just the sum of these. I changed colors because I forgot what color I was. And this is just the sum of, say, these things, right? And then maybe change colors again. Maybe this one is just the sum of these, give or take, right? And you could kind of see where the sliding window idea comes from, right? Because here, well, I have to use another color. You could see that this box, which gives you this answer, and this box, which gives you this answer. I mean, if you don't understand sliding window, definitely go back and do sliding window problems. I apologize. It's 2:20. Larry wants to sleep. but also, like, you could see the sliding part, right? It goes from pink slide to the purple, and in a way, sliding window kind of way. I mean, I know that I'm a little bit hand wavy in this. If you don't know sliding window, it's hard to go from scratch for me. For today anyway. It's just that we have, well, this part doesn't change the color though. So this part doesn't change. We just subtract this part and we add back this part, right? That's it. I mean, it's a sliding window. And this visualization is all you need, right? Once you're able to visualize this in the overlaps, and honestly, maybe another way to think about it is just you look at this, right? Well, you go and calculated F1. So yeah, and you already know all these numbers up to f to the 10. Then now you just have to, well, take f1 and then subtract this number, right? Same thing I'm saying, just in, like, you know, more algebraic, I guess. Yeah. So that's basically the idea of solving this problem. And again, there is Q matrix. Someone always tells me like random things. Trust me, I do know a lot of other solutions. I just don't always bring all of them up because I think sometimes it's just confusing. But in any case, you can look up Q matrix. You can solve it that way for sure. Definitely would, you know, I don't know. Just recommend trying and yeah. I mean, I don't know. Yeah, I don't know. I was gonna say maybe give it a try. I don't even know if it's worth learning. I mean, I think this idea is a little bit more general, so maybe that's fine, right? Anyway, yeah. So then now we just have to go, well, create the thing, right? So here we have, let's just call it DP, because again, just like Go, it's a silly name. I don't know, right? Maybe we write none times. Again, the reason why I left it up is because we want current to be this max thing, and it goes from k minus 1 to max points. We don't want to plus 1 to it, you know, because that's how array indexing works. So k plus max points or mad points, right? Oh, this is a small k. Yeah, I like bigger k's. Oops, not KKK though. Okay, right? And then now we get yeah, we have to let's do the base case first. Base case is, where's base case? Where is it? Okay, so anything bigger than k, right? So basically, let's go, right? So for I in range from k all the way to k plus max points, then dp of I is equal to 1.0. This is just base case, because, wait, no, I'm wrong, sorry. Well, you do have to do this loop, but the base case of this is wrong. I forgot about n, right? So n or less. So if I is less than or equal to n, then this is true. Else, then this is 0.0, right? That's base case. Hopefully it's settled this time for real, right? And of course you could do this in either order. Maybe going backwards makes more sense because it's consistent with your ideas. But again, you see it doesn't really matter, right? Because it's just about this loop and they're all the same and they don't depend on any other values, right? And also we want to the zero number, at least the way that's the way that we wrote our memorization. You could write it up backwards and forwards, I don't know, right? And then anyway, and then now we do want to go backwards. We will start with k minus 1, bit k minus 1. We will go all the way to 0, right? And that's the reason why I write none, is because if it's not, then you'll know it shouldn't be. But yeah. Now we have to do the sliding window bit, right? So let's just say called window is equal to 0.0, and we want to say we have max points. So then the current window, let's just say at k minus 1, you could do for loop ones, right? So for I in range of max points, let's say window, we add dp sub let's see, so k plus I, right? And that's it, I think. Yeah. So this is the window. Maybe you could divide it by max points. You could not divide it by max points. It's fine. It's just the sum of all the numbers in here, right? And now you can see that it goes sum from k to k plus max points minus 1, right? So this is actually already good. So then now you could say dp of I is equal to window, right? Divided by max points, because this is the sum, but you only have 1 over max points to go to each of those places, right? And maybe I'm off by 1, but I think this is right? I mean, But yeah. Okay, and then after that, now we have to process the window, right? Because this is the window, and then now we have to update the window, which is that it wants to add dp sub I, because it just processed it. Now it's in the window, and then we want to subtract the other thing out the window, which is dp of I plus max points, I want to say. Just double checking in my head, because it's easy to be off by 1, right? But I think so. K minus plus, so you are at I is equal to k minus 1. K minus 1 plus max points. You just slid out that one. Yep. Okay. I think this is right. But yeah, and that's it. Hopefully. Okay. I had to be like, well, and that's it. Except for this thing we're gonna fix because I made a mistake. No, so okay. I mean, we test the max case. So it looks okay. It doesn't time out, and it's good, pretty precise even, or as precise as it gets. So let's go give it a submit, and that's it, right? That's all I have for this one, pretty much. This actually, honestly, I think some of it's that I just didn't look at the constraints. So this was trickier than I expected. So my apologies for kind of just, I don't know, messing around in the beginning, because I thought it would be an easy problem, to be frank. What did I do last time? I guess I did the same thing with sliding windows. All right, well, because I would also say, just to be clear, and I don't remember when I did this, just to be clear, this is an idea that, I mean, I kind of knew it from here and there, and I solved it, problems, one is over here, but I never really articulated until, like, say, 2-3 years ago. So still very recently in my competitive programming training career. So you could, I don't know, whatever you want to say by that. But it is an idea that is kind of interesting about just visualization about the grid. Once you are able to visualize the grid, a lot of these problems do become a bit easier in just, like, try to figure out how to make it so that, sliding window, deep, like, do you even call it sliding window DP? I don't know. But that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.